Okay, fine. You know where we're looking? Yeah? You're happy just looking ahead? That's fine. No problem. Okay, so what does variable mean? Sorry? Yeah, changeable. It means you can literally change things, okay? So let's see what we have, okay, on the screen. I think a variable is something that can change, absolutely. More specifically in statistics, when we're dealing with a variable, it's simply just a characteristic of interest, okay? So in this case, when we were looking at our jelly beans, my variable was the number of jelly beans that were in that jar. Does that make sense? Okay. I could have equally been looking at sort of data to do with the college, and a variable could be to do with heights or ages. That could be another variable. Okay. Or it could be the number of men versus the number of females. So gender, that could be another variable. A variable is just simply a characteristic which you are interested in investigating. Does that make sense? Yeah. Cool. Okay. What's next? Discrete variable. In fact, the next two kind of go together, discrete and continuous. Has anybody kind of in a position where they think they know the difference between discrete and continuous? Good, okay, so one is kind of you can think of as a line that doesn't stop, and another one you can kind of think as stop, start, stop, start, stop, start. Which one is which?
Continuous, that doesn't stop.
You happy with that?
Continuous variable has infinity variable.
Yeah, absolutely. Some really good ideas going on, okay? So a discrete variable means that it can only take specific values, okay? And we tend to think of that as something which can either stop and start, stop, start, stop, start. Whereas a continuous variable is something that can take an infinite number of values. It can take any value you like, okay? So it might make sense to illustrate this with examples, okay? A discrete variable can only take, well, I put on there only integer values. What does integer mean? Integer. Integer just means a whole number. Now, actually, that's not strictly speaking true because you can also have decimals as well. But in general, a discrete variable applies to integer values, okay? So, for example, age would be a discrete variable because you can only be 1, 2, 3, 4, 5, etc. Okay? Whereas if you wanted to think about a continuous variable, there's no gaps between the values. So an example would be height, okay? Because you can be 142 and somebody else could be 142.11117, for example, okay? So you don't just sort of go from there to there, you don't just sort of jump in height, you grow continuously, you don't stop growing.
And the age also grows continuously.
Good, good. Tell me a bit more, why?
Because it is end.
Okay, yeah. So we tend to say with age, just to clarify that point, and I can see exactly where you're coming from. Boys, can I just ask for a bit of quiet? Okay. Yeah, so we tend to say with age, you're either 42 or you're 43. We tend not to say you're 42, 3 days, 4 months, 7 milliseconds, 6 micro. Don't tend to say it like that, but I get where you're coming from, okay? A better example then of a discrete variable, so if I'm allowed to go back and correct myself, a better example of a discrete variable would, for example, be shoe size, okay? Because if you go into a shop, you can only buy a shoe of particular sizes, okay? So for example, my shoes are size 10, the next size up would be size 11, okay? You can't get a size 10.76 recurring, okay? So it only occurs in specific intervals.
So that's discrete.
That's discrete. Okay, discrete is kind of like there's jumps between them, there's gaps between them. Whereas continuous, there's no gaps between them. It can take on any value you like. Does that make sense?
Yes.
Okay, so if you have a look at the data set which I gave you, okay, you can see in some of the cases there's some guesses which just do not make sense. So remember the guesses for the number of jelly beans in the jar. There's some guesses which don't make sense. For example, I've got on the screen 71.246281. Okay, you know that that doesn't make sense. Why?
Because the jelly bean can't split, yeah, it's a whole one.
Exactly. So we're saying in our case, our variable is the number of jelly beans in the jar, and are you happy it has to be, well, which one, discrete or continuous?
Continuous. No, discrete.
It has to be discrete. The number of jelly beans that are in that jar has to be discrete because it's either 1 or 2, not 1.7653 recurring. Does that make sense? So it's got to be a whole number. That's what we're expecting. Okay. So yeah, in this case, with our jelly beans example, we're dealing with a discrete variable. Okay, so it's important to be aware now of the difference between discrete and continuous. Make sense?
Yeah.
Okay, cool. What does quantitative mean? In fact, the next two go together, quantitative and qualitative. What do they mean? Two words. So, Mahana, do you want to go first?
Yeah, I think quantitative is only numerical.
Okay. Qualitative.
Qualitative has more, could have more meaning or description.
Okay, so quantitative is numerical. Qualitative is like text and things like that. Do you want to add anything? The same thing? Okay, cool. Okay, that's absolutely right. Okay, so quantitative, it sounds like quantity. In other words, you are expecting a number. Okay, whereas qualitative, it sounds like quality. Now, if you describe the qualities of something, you generally describe it using words. Okay, so in fact, when you're analyzing data, you can think about it as either quantitative data or qualitative data. Okay. Now, in this course, we're going to deal mostly with quantitative data, like numerical data, numbers, okay? But qualitative data, that's a completely different beast, okay? So if you're a psychologist, you may well look at qualitative data. For example, if you're conducting interviews, you need to know how to interpret the interviews, because that's textual data. Does that make sense?
Yes.
Okay, good. Okay, final two then, population and sample. What are they?
The whole jelly bean is the population.
Good.
A handful is sample.
Perfect. So the example which I used last lesson, okay, population in our case would be the entire jar of jelly beans, okay, whereas the sample would be that handful which I took out, okay. So in other words, a sample is just a random group that is taken from everything that could possibly happen, okay. So the entire group would be the population. The sample would be just part of that group. Is that okay? Okay. So I'm always reluctant to just give you loads and loads of definitions because it can be quite heavy, and I appreciate for non-English native speaking people it can be quite difficult, okay? But I think I kind of highlight the most important ones for this theme on that slide there, slide 22, okay? So if you're happy with all of those, can we move on? Yeah? Okay, cool. So come back to our example then, okay? We said that our population is the entire jar of jelly beans and the sample is just like a handful, okay? Now, remember, one of the ways that we could estimate the number of jelly beans, I said, if we weighed that handful and if we had the luxury of being able to weigh the entire population, then we could deal with the sample and then just scale it up to work out what was happening in the population. Does that make sense? Yeah? So if I told you that I took a handful of jelly beans and there were, let's say there were 17 jelly beans in this handful. If I then told you that that sample, the one on the right, weighed 0.18 kilograms, and if I told you that the entire population weighed 1.8 kilograms, how could you work out the number of jelly beans from that information?
That's 10% of the total population.
Yep.
So you multiply by 10 and then you get the number.
Exactly. So if you know the number of jelly beans in that sample, you know how many times bigger the population should be compared to the sample, then you can just scale it up to work out how many jelly beans there are in the population. So that's one way that you could do it, okay? One way that you could do it. But this only works if you have that information about the population, okay? If you didn't know how heavy that population was, if you didn't know how heavy that jelly beans, the jar of jelly beans was, could you make that same assumption? No. Okay? And this is what we'll talk about more and more in this course. This is what you'll find. We're going to talk about sampling because a lot of the time it's physically impossible to understand, to measure the entire thing which is happening in the population. Like if you wanted to work out the average height of people in the entire world, it would be impossible to go round and measure all 7.7 billion people in the world. So a lot of the time what you need to do is deal with a sample, and then you need to understand how to scale that information up to the population level. So this is kind of a recurring theme which we'll meet again in theme 3, theme 4, and theme 5. Okay? So understand the difference between a sample and a population. Okay?